I have created a Python program for exercise 1 of the book and opened it in Visual Studio Code. I will go to Terminal and start a new terminal inside the folder, and there I can execute the program by typing Python followed by the name of the file. Enter and we have the results. The first drill asks us to make the script print another line besides what we already have. Easy. Let's go under the 7th line of our script and type a new print method and write inside it whatever text you want inside quotes. Save the changes with Ctrl S or by going to File, Save, and execute the program again in the terminal below. We can now see that the new line we just typed in our script has been printed. The second drill now asks us to print only one of the lines of the program. Well, let's say we want only Hello World printed, so we can just delete everything else, save the changes, and execute the script again. Now only one of the lines is printed just as the drill requested. I'll return back the lines as they were by pressing Ctrl Z on the keyboard or going to Edit, Undo, and save the changes before moving on. The last drill asks us to put a hash sign before one of the lines and see what it does. I'm randomly putting it at the beginning of the 7th line, and we can immediately see that our editor grays the line out. I will save the changes and execute the script. All the lines are printed in the terminal except the 7th line, the one that has a hash sign. Our conclusion is that the hash sign makes Python ignore a single line of code. I have copied the exercise 2 script in a new file, and after saving the changes I can execute it in the terminal with the keyword Python before the name of the file. We can see printed only 2 lines, even though the script has plenty of them. As we saw in the first exercise, the lines with the hash sign in the beginning get ignored, and that is the reason the terminal doesn't print us anything else. So we were right. The octathorpe or the pound or hash sign in the beginning of a line makes Python ignore that code. If I were to remove the hash sign before the line 7, we can see the code getting colors from the editor, and executing the script after saving it will make another line appear on the screen. As we can see on the 4th line, the hash sign doesn't have to always be at the beginning of the line. The idea is that Python ignores everything after a hash sign. So we can make comments even at the end of a line of code that will get executed. The study drills ask us if we have made any errors when copying the code of exercise 2. There are no errors in our code, but what we could have done is forget one of the hash signs. For example, if I remove the pound character at the beginning of line 6, we can see lots of red underlines in our code. Trying to execute it will run us into errors, because Python doesn't understand what that sentence means as we do. Let's comment it out again and save the changes. I have copied the exercise from the book in a new file inside our folder, and if I were to execute it in the terminal, Python would show me the results. We have plenty of lines telling the user what the next action is, and the real action with mathematical results. The first drill asks us to write a comment above each line to explain what that line does. Starting from the first one, I can write that I'm printing to the user what the program will do next. Then I calculate the number of hens before calculating the number of roosters. I'm not doing all the repetitions here, but before line 16 I can say that I'm comparing two results. The next drill reminds us how the book shows to open Python on exercise 0 and do that again to make some math calculations. At the terminal below on VS Code, I'm now only typing Python before pressing enter. This will start the Python interpreter, and here we can type any command and immediately execute it and see the results. I can try doing some adding, some subtractions, some multiplications, divisions, maybe put them all together in one calculation, and also do some comparisons to see if they are true or not. I can also do a modulus operator to see the remainder of a division. To get out of this now, you can type quit followed by parentheses and press enter. The third drill requests us to find something to calculate and create a new Python file for it. I'm thinking of finding the hypotenuse of a right triangle with the Pythagorean theorem, so I'm creating a new Python file first. Inside, I'm declaring the two sides of the triangle we know, and the hypotenuse would be equal to a squared plus b squared, and all this should be under a square root. To do this in Python, I'm importing the math module and invoking the square root method. At the end, I will print the length of the hypotenuse and execute the script in the terminal. Now I can change the lengths of the sides and see different results of the hypotenuse. The last drill asks us to rewrite the numbers in the exercise 3 file to floating point numbers. This will make them more accurate, but there will be no breaking changes in the calculations when we execute the script, except some numbers will now have 0.0 at the end. I have copied the code of exercise 4 in a new Python file, and if I were to execute it in the terminal below, Python will show me these results. The first drill points out that in the variable space in a car, a floating number of 4.0 is used. But is that necessary? Well, the idea of the variable is to tell how many people can the car hold inside. So I would say using a floating point number is not necessary, because we count people in whole numbers and not in fractions. Removing the 0.0 at the value of the variable, the result will now show we can transport 120 people and not we can transport 120.0 people. The second drill reminds us of floating point numbers. They are just numbers with a decimal point. Just by putting a point followed by a number turns an integer into a floating point number in Python. The exercise 3 covers floating point numbers, so check that video out. The next drill asks us to write comments above each of the variable assignments. The first 4 ones are self-explanatory, so I'm doing the remaining ones. We can say above line 7 that we calculate the number of cars that won't have a driver. Then we declare a new variable to hold the number of cars that will have a driver, which is basically the same as the number of drivers. Then we calculate how many people all the cars hold. And in the end, we find the average number of passengers inside the car by dividing the passengers total with the cars with drivers. The fourth drill wants us to make sure what the equal operator does. Basically, when we declare a variable, we ought to give it a value, and we do that with the equal operator. The latter takes the value from the right side and assigns it to the left side, which is the name of the variable. The fifth drill reminds us of the underscore character. Our program has used this character in the names of the variables. In Python, the convention is to name the variables using snake case, which turns the empty spaces in a sentence into underscores. For example, we have average passengers in a car as the name of the variable. Doing this with empty spaces would result in an error, because Python thinks that each word is a keyword in your script and doesn't understand the meaning, so we join the words using underscores. The last drill asks us to open the Python interpreter in the terminal as we did in the last video, but this time do the calculations with variable names. I will start the interpreter in the terminal by just typing Python and pressing enter. Now we can create variables and assign them values. For example, I'm creating a variable called a and assigning it the value 10. After pressing enter, nothing will show up, but if I were to print the variable now, the interpreter will show 10. I'm declaring another variable b with a value of 5 and another with a value of 7. Now I can do some random calculations with the 3 of them and the interpreter will show the results. I have copied the code from exercise 5 in a new Python file inside our folder. Opening the terminal and executing it with the keyword Python will show me these results. The first drill asks us to change the variable name so they don't have the my underscore at the beginning. Basically, all the variables have that prefix, so I'm removing those one by one, and I'm also changing the values of the variables. Now they are no more the authors. Visual Studio Code gives us some yellow underlines, which are problems in your code. Executing the script again will show us that the variable myName is not defined at line 9. The drill also warned us to change the variable names everywhere they are used, and not only where we assign them values. So we also have to remove the my underscore prefix inside the strings and where we calculate the total. A simple way to do it in VS Code is by highlighting the text we want removed and then pressing Ctrl D multiple times until each word is highlighted. A simple backspace is enough now and the code should work. The second drill asks us to create some variables that convert the inches and pounds of the height and the weight to centimeters and kilograms. I'm declaring a new variable to save my height in centimeters. Turning inches to centimeters requires multiplying the first with 2.54, while my weight in kilograms, which I will save in another new variable, requires to divide the pounds with 2.205. At the end of the script, I'm printing a new message with my height and weight using international units, and I will run the program again. We saw in the last exercise the printing of a new type of string. It had the F character before opening the quotes, and inside we can print the value of a variable by putting it inside curly brackets. This is called an F string, and if we execute now the script, we get these results. There is also another way to format a string, and you can see that in line 17. We can apply the format method to a string by giving it another value inside the parentheses. This value right here is inserted in the empty curly brackets the first string has. At the end of joke evaluation, you can see a couple of curly brackets that have nothing inside. By using the format method, we can get the value of hilarious and put it inside those. Going through the script, we can see that formatted strings are used several times. First, we get the number 10 of the variable types of people and put it inside the variable x. On line 6, you can see that there is no limit at how many variable values we can put inside the formatted string. Here we use the variable binary and that of do not inside the same string. The last line of our program does what is called a string concatenation. It takes two string values which are inside the variables w and e and prints them both with a plus sign in the middle. The plus takes the value of the first string and merges it with the second one. The result will be a longer string that you can see printed in the terminal. One last thing I want to point out in this program is the use of quotes. To create strings, it doesn't matter if you use single or double quotes, but it matters if you have the same quotes inside the string. Line 12 shows this example really well. If I were to put the value of the y variable inside double quotes, the same quotes that the formatted string has, then Python will show me an error. This happens because we start the string with a double quote, and Python thinks we end it here. The curly brackets, if they are not inside the string, are unexpected characters. In this case, what we can do is wrap the string with double quotes and use single quotes inside it, like the author has done it in the exercise. But we can also do the opposite, wrap the string in single quotes and use the double ones inside. After copying all the code from exercise 7 in a new Python file, I can run it on the terminal and have these results. Let's explain what each line does. The first is a simple print method that prints the string inside the parentheses. Next, we use the format method on a string that inputs the word snow inside the empty curly brackets. We then do another simple print followed by something new. Inside the fourth print method, we have a dot as a string multiplied by 10. As we can see in the terminal, this has resulted in 10 dots. So what this line does is takes the string and repeats it as many times as we say. If I were to change the 10 to a 20, we can double the number of dots. And if I were to change the dot into a ha, we can have a good laugh. I'll undo my changes and continue. Now we have 12 new variables with each containing a character. Line 20 does a string concatenation, which we also mentioned on exercise 6, of the first 6 characters and has a weird AND thing at the end. The last line concatenates the remaining variables, and in the terminal we have printed cheeseburger with an empty space in between words. Maybe that space has something to do with the AND thing, who knows? The author has written us a comment to try and remove that AND and see what it does. So let's do that and execute the script again. Instead of the empty space, we now have a new line between words. Let's return the AND thing and put something else inside, like a dash sign for example. Okay, now we have cheese-burger. Whatever we put here is printed at the end of the word. The AND thing inside the print method is called a parameter. By default, it has the value of a new line. That's why, after something is printed, the next thing will be printed below it. The print method in Python offers this parameter, so we can choose how to end the string we're printing.
More carrots. Don't tear it. More carrots. Where's Garrett?
Vegetables. Vegetables.
Here I come from the west side.
If I run the code of exercise 8 in the terminal, I get some weird results that we will try to make sense of in this video. Make sure to subscribe for more videos like this. In the first line, we have a string made of 4 couple of empty curly brackets. As we have seen in the last videos, empty curly brackets inside the string act as a placeholders when we try to format the string. The variable where we have saved our string is called formatter, so something like this should be the idea behind it. Moving forward, we have several print methods, each doing their own stuff. The thing they all have in common is that they use the format method on the variable declared in the beginning and provided different values. What this means is that each of these values will be put inside their respective empty curly brackets of the formatter string. Let's take the first one. Inside the parentheses of the format method, we have the numbers 1, 2, 3, and 4. Checking the terminal below, we can see printed these numbers on the first line of the result. Number 1 has gone inside of the first empty curly brackets, number 2 on the second, and so on. Now let's check the second print method. We now have the same numbers represented as text. Each of them has gone inside the empty curly brackets, and we can see in the terminal all of them printed in the same line, separated by empty spaces, just like the formatter string has separated each couple of empty brackets. On the third print method, we now have boolean values of true and false. They go one by one inside the formatter string, and this proves to us that it doesn't matter what type of values we want to put inside the brackets. They all get converted into a string, as we can see in the results we have on the terminal. The fourth method gets a bit tricky. On each empty curly bracket inside the formatter string, we put itself. So, the whole string, which consists of 4 couple of empty curly brackets, gets put inside the first one, then again in the second one, and so forth. Checking the result we have below, we can see 16 couple of brackets. The same string is repeated 4 times in a somewhat recursive manner. The last print method does the same thing as the second one. It just inputs string values inside the brackets. The only difference is the way the code is written, something we could have easily done also with the others. But in this case, the result is more readable. And the last thing I want to show you is changing the formatter string. If I were to put a dashed line between brackets instead of just a white space, the result would look like this. More printing exercises. Great! After copying the code from the book on exercise 9, I can execute it in the terminal and get some pretty results. In this video, we're gonna try to make sense of this code. Don't forget to subscribe if you haven't already. The first variable holds the days of the week separated with a single empty space. The next one holds the name of the months, but these are separated with a \n. This is a special type of character which, as you can see from the printed result, generates a new line. After January, February goes into a new line. Then the same thing happens with March and so on. This special character goes inside the string just as normal text, but Python translates it into a new line. This is a great way to write less code, because if we didn't know how to do new lines like this, we would have written 8 print methods separately. Now we stumble upon a different way of printing multiple stuff with the print method. Remember when we did string concatenation with the plus sign? We can do the same thing by separating the values with a comma. The print method can take as many values inside the parentheses as you want and they will get printed together. The last code of our script, which stretches into multiple lines, is yet another way of printing stuff with Python. From the green color of Visual Studio Code, we can say that we're printing a string. This particular string starts with 3 double quotes and also ends with them. But checking the result in the terminal, we can see the string has printed exactly as written in the code. This type of string respects the new lines and we don't need any special character. Writing code like this is more readable and doesn't get you confused like the one above. In this exercise, we're going to do some more printing. Don't worry, because from exercise 11 we have some new cool stuff. Don't forget to subscribe for more videos like this. Try copying the code in a new file in your editor and look carefully inside the strings. You can see many backslashes this time, like the one we saw in the last exercise to generate a new line. That one was \n, which we can find again a couple of times here. But let's start from the first variable. At the beginning of the string we have a \t, and the text says that it's tabbed in. Let's take a look by executing the script in the terminal with the Python keyword. The first line printed has a lot of empty spaces before the start of the line, so the purpose of \t is to make a head start, just like pressing the tab character. Now let's see the Persian cat. It has a \n, so we already know it generates a new line and it splits the string in the middle. In the result we have split on one line and on a line below it. We see this character again on line 9, but let's take it slow. The cat has 2 couples of backslashes. We know that the backslash before a letter can do something, but what's the point of a backslash before a backslash? The idea is that whenever Python runs into a backslash, it expects something next to it. The \ character is called an escape character in Python, so it escapes what is next to it. This means that there would be no way to simply print a backslash in a string. That's why the backslash escapes itself, and you can see printed only one in both cases. Now we have the same 3 double quote string that respects the formatting of the new lines inside it. But we can use the \n character if we want, like the author has done here. This could have been like this and it would be the same result. The author has also used \t to give the list of things some space so they look nicely on the terminal. In one of the drills we are asked to convert the quotes here in single ones, and if we were to do that we would run into an error, because we have a single quote here and Python would think the string ends here, like the case we saw a couple of exercises ago. Or would we? Let's try and we can see that everything is correct. These three quotes together really do miracles, and they don't care what quotes you have used inside. And since we are here, I have one last thing to show you. I will create a variable that will hold a string, and printing it like this would be fine. Changing the double quotes into single quotes would run me into the problem I said before. Python thinks the string ends here, but I really want single quotes in my string, so what do? All hail the backslash character. Putting it before the single quote inside the string escapes it and prints it normally in the terminal. The same thing would also work with double quotes. As the book says, now it's time to pick up the pace. We've done some pretty boring exercises with lots of printing, so now buckle up and get ready to learn some cool stuff. Don't forget to subscribe to the channel if you haven't already. I have copied the code from exercise 11 on a new file inside my project folder. We have 4 print methods which we're familiar with, but we also have an input method which we haven't seen before. By the way, you can be sure something is a method if you see a pair of parentheses after its name. But what does the input method do? I will open the terminal in VS Code and execute this script with a Python keyword. What's happening? In all our 10 exercises before, the script had finished executing immediately, and the terminal was ready for other commands. Now it's waiting, and it's asking for our age. Let's type it and press enter. Next, it's asking for my height. Fine, here you go. Enter again. And now it wants my weight. I'll give that too and press enter again. Finally, the script has finished executing and it printed us a message stating what information I gave before. Interesting. So, what the input method does is make the terminal wait for my response and catch that so it can do something with it. Let's explain the script line by line. At first, we print a message asking for the user's age. Remember what the end thing was called? It's called a parameter, and it defines how the line printed should end. By default, it generates a new line, but here we're saying to just leave one empty space at the end of the printed message, so the question experience is better like we saw. Now we have a new variable called age, which is equal to the input method. Whenever Python faces this method, it stops the script execution and waits for the user's response. After the user presses enter, the input method catches the response and, in this case, stores it inside the variable called age. The same thing also happens with the variables height and weight. In the end, we have a formatted string that prints a message to the user stating the user's age, height, and weight in a sentence. Beautiful. The last drill asks us to do something like this ourselves, so let's try. I'm deleting the existing code and I'm starting with a print method asking the user about their favorite movie. I'll leave one empty space at the end of the line and I'll use the input method to wait for the user response. Then I will save the latter in a variable and I'll do the same for the user's favorite book. In the end, let's print a message with the 2 new infos we have. Now I'm going to execute the script and answer to our computer. Amazing! With just a couple of lines, we have finally grasped the beauty of interacting with a program like we do every day. In the last exercise, we saw how to ask for the user input with the input method. In this exercise, we are going to do the same thing but with less lines of code. Please subscribe to the channel for more videos like this. Here I have the code of exercise 12 of the book, and if I run it in the terminal, it does the same thing as the code of exercise 11. But what has changed? In our previous code, we had a print method before each of the input methods. Those assured us to print something in the terminal so the user knows what to give us back. Now we have the same text inside the parentheses of the input method. This means that the method allows us to give data to it and then it does something with that data. In programming terms, the method has a parameter and the value we give inside the parentheses of the method is called an argument. In this case, the input method takes our string and prints it in a terminal before waiting for the user input, just like we did in the last exercise. But how do we know what the methods can receive inside the parentheses? For this, we can use the Python documentation, which you have installed in your computer by default when installing Python. In the terminal, just like when you execute the scripts, try typing python-m pydoc followed by the name of the method you want more information about, the input method in this case. After pressing enter, the Python documentation will show you a couple of paragraphs explaining what the method does. Inside the parentheses, we have prompt equal to none. This is the parameter I was talking to you about. It's called prompt and it prints a string in the terminal without a trailing new line. That's why we have an empty space at the end here. By default, the prompt is equal to none, which means it has no value. When we called this method with empty parentheses in the last exercise, it still worked. And that's because the prompt parameter has a default value of none. If you want to read how other methods in Python work, run this command again, but change the name of the method.
Anywhere you go, give it on. Anywhere you say, anywhere.
Things now get a bit complicated. Trying to execute this script after copying it exactly from the book will throw me a value error of not enough values to unpack. But have we done something wrong? That's what we'll see in this video. Make sure to subscribe to the channel if you haven't already to get notified for new videos like this one. Here we do something new from the first line. This is how you import stuff inside your Python script. Python is really lightweight, which makes the programs written in Python execute really fast. But you don't have a lot of features in a basic Python program. And that's why we need to bring new stuff from elsewhere. We have written here that from sys we want to import argv. But what are these? From is a keyword that specifies the location where Python should look into. And import is another keyword that brings something inside our script. But what are sys and argv? Well, in Python we have these things called modules, which are just files containing Python code. There are some that come by default when you install Python. But there are also many more that you can install separately. Think of those as just Python scripts, like the ones we have written until now together, but written by others that may help us. In this case, sys is a module in Python, and you can verify this by hovering over its name in Visual Studio Code. The new window that appears gives you an explanation of what the module does and what it offers for us. The first thing in the list is argv, which, as we can read here, is a dynamic object inside the sys module. So what the first line in the script does is import a dynamic object called argv from the sys module directly into our script. If we hover over argv, we can see that it's an object of type list that can hold strings inside. Printing argv would show us a list of strings in the terminal, but in line 3 we do an operation that is called unpacking. In simple words, we take each element of the list and assign it to a variable. This line has created 4 variables called script, first, second and third. We expect 4 elements inside the argv list, so the first element would be assigned to the variable script, the second element to the variable first, and so on. Then the script just prints the value of each variable with useful information. But how do we execute this script? Well, argv stands for argument vector, so it is a list of arguments. And remember how we execute a Python script? We say Python followed by the name of the script. And the name of the script is an argument we give to Python. If I press enter, I get the same error as before, but if you read the error until the end, you can see that the argument list expects 4 elements and only got 1. The only one was the name of the script. Let's give it 3 more. You can do so by just leaving an empty space between arguments. Make sure you have 4 arguments after the Python keyword and try pressing enter again. Now it finally works. The name of the script went into the variable called script. The cat went inside the variable called first, dog into second, and snake into third. Beautiful. But what if we want to give another animal to our script? Let's try and do that in the terminal. I repeat the same command I executed before by pressing the up key on the keyboard. I'll add shark after snake and press enter. Another error, but this time we have given more values than the ones we are trying to unpack from the list. I'll add another variable separated by a comma and do one more print method at the end. Now the command should work. Keep in mind that there is no limit to arguments we can give. The errors we have seen till now have happened because of the unpacking we tried to do. I'll delete all the code except for the first line and just print the argv list. If you execute the script now, we can see printed a list of all the arguments we gave after the Python keyword. I'll add a couple more and they'll just appear inside the list. In this exercise, we are going to combine plenty of stuff we have learned till now. Make sure to subscribe to this channel if you haven't already. I have copied the code exactly from the 14th exercise in the book, and if I were to run it, I will run into the same error as in the last exercise. The error is in line 3, and it says that there were not enough values to unpack. The script expects 2, but only got 1. We can see on line 3 that the argv list gets unpacked into 2 values, script and username. By executing the script with this command, we provide one argument, the script name. So we have to give another argument that will be the username. Let's do that by leaving an empty space and press enter to run the script. Now it seems to be working and the program is asking me a question. I'll answer and press enter. Here's another question. I'll answer again and here's another one. Answering this will terminate the script and the paragraph with all my answers will be printed on the terminal. It was like a game, and as the book points out, it was like the game's Zork or Adventure. Beautiful. We're finally doing some really cool stuff, but let's see how the script works. First, we import the argv list from the sys module. We saw how this worked in the last exercise. Now we do a process called unpacking, where we take each item inside the argv list and assign it to our variables of choice. In line 4, we have a variable called prompt that is just a string with a greater than sign followed by an empty space. This is now followed by 3 print methods, 2 of which contain formatted strings that include our 2 variables inside curly brackets. This kind of syntax prints the value of the variables as we can clearly see in the terminal. Now we have a new variable called likes, which is equal to the input method with a prompt variable inside the parentheses. But what does this do? As we have seen before, whatever string we put inside the parentheses of the input method, it will show in the terminal just as the script is waiting for the user input. If I return to the terminal when the script asks us if we liked it, we had the greater than sign before our answer. This is just a nice and clean way to prompt the user for an answer. Let's try and change the sign into something else. For example, I will say answer followed by a colon. Remember, you only have to change this once in the value of the variable prompt. Each input method will get the same value after. Run the script now and see the difference. The last new thing we have in this exercise is the print method at the end of the script. Sure, we have seen the triple quote string before, but what the author has done here is use a formatted string with the triple quotes. That's right, we can also do this and save ourselves some time and writing. The author also asks us in the drills to add a new argument in our script. Let's say I wanted to provide a title for this little game. Adding it when we execute the script will show us an error because there are now too many arguments. To resolve this, we should add a new variable in line 3 where we unpack the argv list. Now there should be no errors, but the title we gave to our script doesn't show anywhere. I'll edit the first print method to get the user introduced with the title of our game. I left the script running in the terminal, so to save some time and not answer the questions until the end, you can stop the execution of the script with Ctrl+C. Running it now will also show us the title of the game. Now that we know how to unpack arguments and get input from the user, we are going to look in one of the most used features in Python, reading from a file outside our script. Make sure to subscribe to get notified for videos like this. We know what the first 2 lines of code in this exercise do. If you don't, please make sure to watch the previous videos. In line 5 we have something new. There seems to be a method called open that takes the name of a file inside the parentheses. Remember how we read about what a method does? Open the terminal and type python-m pydoc followed by the name of the method, which in this case is open. The documentation says that the method takes as an input a file, and what it does is opens it and returns a stream. A stream is just a flow of data. After the script opens a file, it saves the stream inside a variable called txt. I will now delete my terminal and move on. Line 7 just prints the name of the file with a formatted string. We know how this works, but line 8 looks like it reads the file and prints it in the terminal. You see, there is this method called read which is used on the variable txt, the stream of the file, and not the file name. So what we do is we first open a file which gets us the data from it, and then we read that data. This looks really simple. Let's try it out if it actually works. Inside our project folder, I'm going to create a new txt file and put some content inside. Make sure you name the file something simple so you don't get mistakes later. Now I will return to the script, open the terminal and execute it by also providing the name of the file we want to read. In this case they have the same name, but the script ends with py and the text file ends with txt. Press enter and we can see the content of the file printed. Great! The script now asks us to type the file name again. Okay, let's do that. Press enter and we have the content of the file printed out again. But how did this work? I'll delete the terminal and check out the remaining lines of code. After printing a message to the terminal, the script asks for the user input with a greater than sign as a prompt. Whatever the user gives, it's saved inside the file_again variable. Then the name of the file is opened and its stream is saved into txt_again. Lastly, the data of the file is read and printed in the terminal. But which way did you like better? I will comment out lines 10 to 15 and give the name of the file as an argument. Now I will comment out the remaining lines and uncomment 10 to 15. The script execution needs no arguments other than the script name, and after pressing enter you are going to be prompted for the file name, just like before. To be honest, I like this way better, because we have made a script that acts as a file reader by interacting with us. The last thing I want to show you is closing the files we open, just like we do on our computer. We don't leave a document hanging open forever, so we have to do the same inside our script. After reading and printing the data of the file, we can use the close method on the stream. This assures that the file cannot be read anymore after, and reduces the size of the memory it takes. After copying the exercise script from the book in a new Python file, I will also create a text file with some text inside, because we're again going to handle files in this video. Please subscribe to the channel and press the bell icon for more videos like this. As you can see, this is the biggest script file until now, but let's not get scared and try explaining it line by line. At first, we're unpacking the argv list into two variables, one that will hold the script name and one that will hold the name of the file that we're going to provide. Next, the script says that it's going to erase the content of the file if we choose to press enter. Otherwise, stopping the execution of the script with Ctrl-C will not do it. Interestingly, the author has left alone an input method on line 9 with a question mark to be shown in the terminal. This means that whatever input the user gives is not saved anywhere and doesn't matter. All that we're interested in is that the user presses enter. That way, the script will continue running after line 9. Now, the script uses the open method to open the file with the name we provide. But besides the file name, there is another argument that consists of a string with a W inside. And what's the meaning of this? When we need to know what's going on inside the method, we can for sure search on Google, but I'm going to use the Python documentation that we've seen a couple of times before. Open the terminal and type python-m pydoc followed by the name of the method we want to read for. As you can see, the first argument of the open method is the name of the file we want to open, but after that we have a parameter called mode that has a default value of r. Notice that the documentation of this method has more information if we want to read, and pressing the space key will reveal more text. Great, we can now read about the mode parameter, which specifies the mode in which the file is opened. The R letter opens the file in read mode, while the W in our case stands for writing. So we have opened the file in writing mode, which makes it ready to accept new changes and save the stream of it inside the variable called target. You can now delete the terminal, but if you want to get out of the reading documentation, press the letter Q. Moving on. On line 15, the method truncate is used on the target file, and what this does is erase the content inside the file. That's why the script asks us first if we're sure about continuing. Now it's writing time. The script asks 3 times for user input. Each line that the user gives is then saved inside a new variable. The script then uses the write method on the target file to write inside it each of these lines. The write method accepts a string as an argument and pastes that inside the file. That's why the author has also written in between the lines the \n character, to make sure we have new lines after those that the user types in the terminal. Finally, the close method to close the file stream. So much information, but let's try and run the script to see the results. Type in the terminal the name of the script followed by the name of the text file you want to write on. These are the arguments that get unpacked into the 2 variables. After pressing enter, the script will tell you that it's going to erase the contents of the file and expects an input after the question mark. We can write here whatever we want, but after pressing enter, the script will continue executing and erase the contents of the file. Go inside the text file and see that it's empty. The script is asking now to write the first line of the 3, so type something and press enter, and do the same thing 2 more times. After the last enter, you can immediately see the lines that you typed inside the text file, and the script has now finished executing. Beautiful! The third drill of the exercise asks us to turn the 6 write methods into just 1, without changing the result. I know exactly how to do that. Since we want the value of the line variables printed out, we can use a formatted string inside the write method. I will type the 3 variables one by one, each inside curly brackets. Now I'll do a new line in between them, and also at the end, like the author has done. The script is now more compact, and executing it again will produce in the text file the same results as before. The last thing I will show you in this video is about the truncate method. One of the drills asks us if we really need that method when opening the file in writing mode. Well, something caught my eye when I opened the documentation for the open method. When explaining about the writing mode, we can read inside brackets that the file is going to be truncated if it already exists. In our case, we already have the file created, which means whatever is written inside it will be deleted and the writing will start from scratch. I guess we don't need the truncate method at all in our script, so I'm deleting lines 14 and 15, and let's try and run the script again, while keeping the text file open. Immediately as I press enter, the contents disappear, so don't worry about emptying the text file when opening it in W mode, because Python will take care of that by default. Time for another exercise. I have created a new Python file and pasted the code from the book inside it. It looks large and there are some new things I can notice that we haven't seen until now. Let's take it line by line and please subscribe for more videos like this. We have already imported the argv list from the sys module. Remember, we use this to unpack the arguments that are provided when executing the script in the terminal. But on the next line, there is another thing imported in our script. The function is called exists and comes from the path, which is a module exported from another module, that of OS. Now comes the unpacking of arguments into three variables. The first, of course, is the script name. Then we are supposed to give two other arguments, a name of a file we want to copy data from and another one we want to paste data into. This is the purpose of our script, as you can see in line 6 where we print a formatted string with the variable values. On line 9 to 10, the original file is opened and read. All its data is saved inside the variable inData, and on the next line we have something new. You can notice inside the curly brackets of the formatted string that we haven't just printed the value of a variable, but we have executed a function called len, which takes as an argument the data of our file. Isn't this great? We can even compute calculations inside strings to save us time and code. And what the len function does is it returns the length of an object. For example, if I were to provide a string inside the function, it will return me the number of characters it has, while providing a list will return the number of items inside it. In our script, the len function takes the data of a file, so what it will do is return the size of the file. Now, next comes another new thing. Again, used inside the formatted string is the function exists that we imported at the top. Hovering over the name of the function in Visual Studio Code will show us a small window that explains what the function does. This here tests if a file path exists in our system and returns true if it does and false if not. On line 16, we have left alone an input method in order to pause the execution and wait for the user to just press enter to continue. We also inform them to press Ctrl+C if they don't want to. Then the second file we provide as an argument is opened in writing mode. Remember the W string in the last video. And all data from the first file is written inside it. Both files are then closed at the end. Shall we try running the script? I will first create a text file and write some content inside. This will be the input file, while I won't create the output file, because the script should do that for me. In the terminal, type Python followed by the name of the script, empty space, the name of the text file we created, empty space, the name of the new file we want to copy our data into. Enter. Turns out the content inside the input file is 53 bytes long, and the output file doesn't exist. Remember, this boolean is returned by the function exists. Let's press enter to continue and the script immediately finished running, while on the left pane you can see the new file created. Try opening it and see the same content as the original file inside. Now that we have an output file called copy.txt, let's try running the script again. I will change some text inside the original file and press enter in the terminal. The input file is now 4 bytes longer, but another important change is that the output file exists. Will pressing enter change the content again? Of course it will. The last thing I want to show you in this video is about the comment on line 8. The author tells us that we could combine the next two lines together, so let's try and do that. Basically what we do here is open the file and save its stream inside the variable inFile. Then we get that stream and read the content it has, which we save in the variable inData. Now, to not write more code than needed, we can chain the methods together. After opening the file, we can immediately use the read method on the stream it returns, and then save the data inside the variable. Don't get impatient to execute the script, because the script has an error now. On line 23, the inFile variable doesn't exist anymore. And that is true because I deleted the line where we defined the variable. Since we get the data immediately from the file, we now don't need to close the stream of a file that we haven't saved anywhere. So let's remove that line and try running the script. No errors. But the way we simplify the reading of a file can also work in simplifying the writing, right? Let's try and chain the write method after opening the output file in writing mode. There are no errors here, but we don't need a variable now. The write method returns the length of the content we wrote inside the file, hence we can just remove the variable and leave the method do its work. And here comes the error. The variable out file doesn't exist anymore, so let's remove that line too and run the script again. But first I will change the content of the original file a bit so we can see if the script really works. Perfect, same result with less code. The title of this exercise may be long, but the important concept we'll focus on in this video is functions, the building blocks of Python programs. Please make sure to subscribe and click on the bell icon to not miss videos like this. After copying the code from the book in a new Python file, we can immediately notice a keyword we haven't seen before, the def keyword. This is short for define, and what it does is it creates a function, or if you want, it defines a function. An empty space after the keyword, we choose the name of the function followed by parentheses. The first three functions we can see have stuff inside the parentheses, which are just variables with a special name, parameters. For example, arg1 and 2 inside the parentheses of the second function are the parameters of the function called print2 again. As I said, parameters are variables that we can use inside a function. When calling a function, we give values to them, as we'll see later. But functions can also be without parameters. In those cases, they don't need external information to work, they just do their job and move on. But keep in mind that the parentheses are required when defining a function, and if you don't want any parameter, you should leave them empty, as is the case with the fourth function. Anyway, don't get too distracted. Just remember that inside the parentheses of function, we can pass different variables and use them inside it. Now let's focus on the syntax. After the parentheses, we have a colon, which is really important when defining a function, because it tells Python where the function code starts. And as you may have guessed, this here is the function code, or the block of code of that function. This is what gets executed when we call the function, and it's here where we can use the variables we have inside the parentheses. Does it make sense to you? Leave me a comment if it doesn't. Another important thing is the indentation of the block of code, those empty spaces at the beginning of each line. Python has taken a simple approach in writing code, without curly brackets like you may have seen in other languages. Hence, it needs white spaces to tell if a line of code is part of a function or not. Try removing the empty spaces, it will be a bad idea. Modern code editors make the indentation automatically for you when you press enter after the colon, and continue doing it after each line. If yours doesn't, press the tab key on your keyboard if you want the line of code to be inside the function. This will generate multiple empty spaces for you, depending on what your editor is configured to. Mine, for example, is set to 4 spaces, so each tab key I press will generate 4 empty spaces. Multiple spaces are only for aesthetic purposes. Python cares only for some kind of indentation. Leaving just one space will still do the work. A shortcut you can use is highlighting all the lines of code you want to indent and press tab. So I told you before about calling functions. The last 4 lines of our script do exactly just that. Do you notice how it's done? Well, calling a function means to just type the name of the function followed by parentheses. If the function takes parameters, then supply values for them inside the parentheses, like the first 3 function calls. One thing I didn't tell you is that the value we give to one parameter of a function is called an argument, as you can read in the comments of the author. But don't mistake this with the argv_list we have imported in the previous videos, although that uses the same idea. Basically, when we execute or call our script in the terminal, the script has a parameter of a list which we can fill with values. So what we do is give arguments to the script. Have you noticed that we haven't imported the argv_list in the script? That's right, all the arg variables you see here are just variable names that the author has put. So we don't need to give arguments to the script when executing it. Let's try doing so in the terminal. Immediately after pressing enter, we can see a bunch of stuff printed and the script has finished executing. No errors. Now let's take each function and see what it does. I'm going to skip the first function for now and go into the second one. It's called print2again, defined by the def keyword, and takes two parameters, arg1 and arg2. Inside the block of code, we have only one print method that prints a formatted string, which includes the values of the variables arg1 and arg2 in curly brackets. So, whatever value or argument we provide to these parameters when calling the function, they get printed in the terminal. Let me try and change the parameter names. Immediately the editor gives us an error under the variables arg1 and arg2, because they don't exist anymore. Some of you may say that we have an arg1 and 2 in the first function, but keep in mind that whatever variable declared inside a function cannot be used in another function. This concept is called local scope. Now I will also change the name of the variables inside the formatted string. But where is it that we give values to them? Scroll a bit down and the author has called the print2again method with two string arguments separated with a comma. The author's name now goes inside the variable called name, while his last name goes inside the variable surname. They both get printed to the terminal. I will change the arguments to my name and execute the script. Beautiful. Now let's go back to that first function. It also has two arguments used in the print method, but as a parameter has something weird. The star operator in front of a variable called args. Do you have any idea what it does? Well, if we want the user of the script to pass in the function as many arguments as they want, then we can use a list of arguments with asterisk in front. In our case, the two arguments, when the script calls the first function below, go inside the args list, which is then unpacked into two variables that are used inside the print method. Get it now? Let's unpack a third variable, the value of which I will add inside the formatted string, and below add a new argument when we call the function in line 19. Executing the script will show us the expected result. Anyway, the way we did this didn't help us that much, because we still have to declare the variables the function will use. But when you learn about loops, you can just do a for loop and print out as many values as the user of the script gives. The third function now is not much different than the second one, except that it has only one parameter. Its value is printed in the terminal, and you can see in line 21 that the author has given only one argument when calling the function. The last function has no parameters. Notice the empty parentheses? It's just a simple function that prints one line in the terminal. There is no need for any external information. We can call it as below, but be careful to also put the empty parentheses when calling the function, and have it execute its block of code. Awesome. So, what was the idea of functions? Why go to all these troubles when we can just print stuff in the terminal in another way? Well, functions are not just blocks of code, but they are reusable blocks of code. Instead of repeating code in our script, we can write a function that does a good job and call it multiple times. Let's say we want to print to the terminal the sum, difference, product, and quotient of two numbers. I will remove the function calls we have in our script to not make the terminal confusing and start printing each expression with numbers 4 and 2. Looks good. Execute it and we have our results. Let's do the same thing with numbers 5 and 3. Too much code, but gets the job done. Now let's do 7 and 6. Okay, now I'm getting tired repeating myself. So, shall we try another way? I will define a function with a def keyword and call the function arithmetic expressions with an underscore in between. Be careful to not leave any empty spaces, or start the function name with numbers or special characters. Now inside the parentheses I will declare two variables, number 1 and number 2. At the end of the line comes the colon, and after pressing enter, Visual Studio Code will start a new line indented from the start. Here comes the block of code. What we want to do here is print to the terminal the same expressions as we did before with numbers, but in this case we will do the expressions with unknown variables. I will first print the sum by also letting the user know what we're printing. then the difference, product, and quotient. Looks beautiful and clean. Now let's get out of the function by pressing the backspace key and try calling it. Remember that the function requires two arguments, one for number 1 and another for number 2. So inside the parentheses, give the function two number values. Execute it now and we have our results as we wanted. To do the same calculations with different numbers, we can just call the function again and again and change the values inside the parentheses. It's really that simple. We didn't repeat ourselves and the code looks way cleaner and more beautiful. We talked a lot about functions in the last exercise, and I went beyond that to explain to you parameters and arguments of a function. In this exercise, the author wants to show us different ways how we can give data to a function when we call it. The script, which I have copied in a new Python file, has defined a function in the beginning that accepts two values inside the parentheses, the amount of cheese and that of cracker boxes. Multiple print methods are then executed inside, two of which include the values I said earlier with formatted print methods. The first way the script calls the function is how we saw in the last video, by directly giving values inside the parentheses. The numbers 20 and 30 in this case are called arguments to the function. 20 goes inside the variable cheese count that is then printed out, while 30 goes inside the variable boxes of crackers that is also printed out in the third line. I will comment out the other lines of code below line 9, open the terminal and run the script with the Python command. You can clearly see the results we expected. Were I to change the values inside the parentheses, they would show up in the terminal all fine. Now I will comment out lines 8 and 9 and uncomment the next lines of code. Remember, in Visual Studio Code, you can comment and uncomment highlighted lines of code with the shortcut Ctrl/ in Windows or Command/ in Mac. This function call doesn't give number values directly inside the parentheses, but the script has first created two variables that hold the numbers 10 and 50. Then the names of the variables are put inside the parentheses as arguments to the function. This way seems like extra work, but it can be cleaner when you decide to do calculations inside the variables. Now we have 25 cheeses and we didn't touch the function arguments. The third function call in our script tells us that we can do these calculations directly into the arguments of the function. I am not sure why someone would do something like this. It's too much chaos, but we're here to learn what Python can accept in our code. Last thing, we can also combine variable values with literal values, and Python first performs the calculations and then gives the results to the parameter variables of the function.